All right, so in this video, we're going to talk about the idea that systems mean simultaneous truth. So our learning goal is I can interpret and solve systems by finding ordered pairs that make both equations true at the same time. Now this lesson will have a lot of connections. It's going to boil down to solving, which is a previous skill, and it's going to kind of carry forward really throughout math, right? Like these kind of systems are going to show up in a lot of different contexts, which we'll see in video C7. Yeah, but this video is just about the idea of that simultaneous truth. So for a hook here, we see a question. A line and parabola both give a y value. So we see y equals x plus 2 is the line, and y equals x squared minus 3x plus 2 is the parabola. Where are they telling the same story? So for pause question, our question is, what does an intersection point have to satisfy? And then I'm going to get you to write a sentence before solving. So take a minute, write a sentence, what that means to you, and then we will take a look at this question in I do 1. Okay, so take a look at I do 1 here. So it's that hook question. So you can see, again, your line in the parabola. So yeah, again, our kind of prompt here is, what does an intersection mean in a system of two linear equations? And in those, we saw they were just the intersection points, right? So we saw with two linear equations, I was kind of sketch them up here, we really had the kind of three cases, right? So case one was two lines hit each other at one point or intersection. Alternatively, they could never hit each other and run parallel to each other. So that'd be one solution, that'd be zero solutions. Or finally, they could just be the same line again, which would be an infinite number of solutions. Same idea with parabola, right? So if you sketch these, you kind of see like these could hit a couple times or not at all. So to solve this question, again, if I take a look at the question says where they're telling the same story. What I want to do is, well, both equations equal y, so why not just set them equal to each other? So if y equals x plus 2 and y equals x squared minus 3x plus 2, let's just set them to each other, because those expressions, those outputs have to be equal at that intersection. So I'm going to say, well, okay, so x plus 2 is going to be equal to x squared minus 3x plus 2. And now I'm going to solve this. So I'm going to pull everything to the right side because I have a positive x squared there. So x squared minus 4x plus 0 equals 0. And this is a really familiar quadratic, right? I can just really quickly solve this quadratic. 0 equals x times x minus 4. So use my zero principle, I can see that x is 0 or x is 4. Now, question might be, am I done? The fact that I asked that probably means no. And this is another kind of side piece of this video. We're trying to find the points of intersection. We want to find the points of intersection. So think about, what does it mean to be a point? Well, a point in 2D space, we know we have an x and a y. So we know x is 0 and x is 4, but each of those x's is going to give its own y value, potentially. So what we can do is we have x is 0 over here and x is 4 over here. And I have two relationships which tell me, hey, like if you give me an x, I'll give you a y back. If you give me an x, I'll give you y back. Now, because we found the x's where that these equations share, what that means for us now is it actually doesn't matter which one we check. And when it doesn't matter which one we check, we're going to pick the one that's easier for us, in this case, x plus 2. So here I'm going to say, if I check 0, I'm going to say, well, y for an x of 0 is just going to be 2. For an x of 4, y is going to be 4 plus 2, which is going to be 6. Now note that this information does pair with itself. So when x is 0, y is 2. And then when x is 4, y is 6. So those are pairs of information. So therefore, at the end of the question, we could say, well, okay, we have our answers. So therefore, the POIs, the solutions, are going to be the point 0, 2 and the point 4, 6. And that's it. So again, note that we wanted to know where these things intersect each other in 2D space, so we did need those second points. So again, our points are 0, 2, and 4, 6. You can check these if you wanted. So you could check if you plug in 0, 2 into both equations, you plug in 4, 6 into both equations, you will get the same solution. I would encourage you to take a look at it, and you can always check a system if you'd like. We can kind of glance at it because we know 4, 6 is going to work. We just kind of created it here. And then 0, 2, I can say that both those, the line and the parabola, both have a y-intercept of 2, which would be the point 0, 2. So those would also work. Okay, so let's go on to the next example. So here's you do one. So this kind of side prompt here is 1 point of simultaneous truth. So here's the system. You have two relations, y equals 2x minus 1 and y equals x squared minus 2x plus 3. This question is, what are you thinking? And whatever you're thinking, just try it now. So try to find that simultaneous truth. Where do those equations agree? And a little hint there is you can kind of see from the kind of context and over here, there is only 1 point. Kind of try to explain what that means. Pause the video, take a shot, and we will talk this one through. Okay. So welcome back. So again, strategy here, I'm saying, well, I have y equals something and y equals another thing. Just set them equal to each other. And we get a perfect square down here, which means we get x equals 2 out. And I just need to plug that x equals 2 again into either equation. And again, I'm going to pick the line. It's easier. And I get 3. So that says that the solution is the point 2, 3, or alternatively, x is 2 and y is 3. Yeah, and that's it. So that is the intersection point. You can write your interpretation there if you have kind of something to add, but yeah. And again, note I am stating the x and the y coordinates. That's going to change shortly, but the way these questions are set up is we are looking for the intersection point, so x and y coordinates. Last question here. I do too. We have two parabolas, but the same idea. So here, instead of having a line, which kind of let us off the hook a little bit, we have two parabolas. So we have y equals x squared minus 4x plus 3 and y equals negative x squared plus 2x plus 3. So we have no line this time. Our question is, what's the same about the meaning of intersection? Well, if we sketch it, what we're saying is, well, we have some parabola. This sketch is not going to be perfect by any means, but I have some parabola opening up and some parabola opening down. Well, those intersection points are still going to be where the x's and y's are equal, where those equations give the same output. So what that means is, again, we have y equals one thing and y also equals another thing. Let's just set those y expressions equal to each other, solve for x, and then work back for y. So we're going to say, well, okay, so y is x squared minus 4x plus 3, but y is also negative x squared plus 2x plus 3. So when I solve this, I'm going to bring my x's together. I'm going to go to the left here because I have my x squared being positive over here. So I'm going to get 2x squared minus 6x plus 0. So there we go. I can solve this. I can factor to 2x, common factor, which leaves an x minus 3. Zero principle tells me x is 0 because 2x is 0, or x is 3. And then again here, I'm going to say, well, x is 0, x is 3 are my solutions. And for each of those, I'm going to work back for y. Now, again, I can pick either equation I want. I'll choose the top equation because it has a positive a value. It's a little easier for me to work with, but 6 of one, half dozen of the other. So I'm going to say y equals, so when I put in 0, I'm going to get 0 squared minus 0 plus 3, y equals 3. So our first point is going to be 0, 3. Our second point, when x is 3, y is going to be 3 squared minus 4 times 3 plus 3. So that's 9 minus 12 plus 3, which is 0. So therefore, that point is going to be 3, 0. So therefore, the points of intersection are going to be 0, 3, and 3, 0. That's it. Again, you can see we have 2 points. Our visual check does kind of show it. But if I did kind of sketch it, I would see that I'm at 0, 3, and 3, 0. If I just sketch these things quick. And I am going to go fast here. I'm going to see those intersections there. And that's it. Little checklist, and I would encourage you, if you want, you could take a look at that and yeah, sketch those out and make sure that these do kind of hit where we're saying they hit. Yeah, it's a good strategy for sure. Okay. Um, yeah, final little checklist for us in this video. So when we're solving a system, things we should be asking. And again, you don't have to ask all these questions, but this is like a nice idea to work with. What does each equation represent? So is it a line? Is it a parabola? Is it a particular relationship? Can you set the expressions equal because they both equal y? So often we have an equation written as y equals something. In that case, we have a really easy substitution. Make sure you're solving for x carefully. If your x is wrong, the whole system is going to be wrong. For your x, are we even asking for points? Are we asked for points? And if so, go find that y value. Are you writing ordered pairs and not just x values? Again, assuming we are looking for points, so we'll find the points of intersection. Did you verify both equations? Again, that's not really necessary, but you can. You're always welcome to verify if you'd like. And then finally, can you explain what that number of solutions means on the graph? So how many points of intersections there are. And that's it for the video. So thanks for watching. Any questions, let me know.